This week on Phys Talk, we'll be learning about momentum.
This is the problem we'll be doing this week. Pause the video, read over the question, write it down, and we'll get right to it.
The initial velocity was 70 meters per second. The final velocity was 30 meters per second. His mass was 80 kilograms. This is the diagram representing the situation.
To start solving the problem, we filled out these two tables. We found the initial and the final velocity in the x and the y direction. To find the initial velocity in the x direction, we did 70 cosine negative 30. The 70 represents the initial velocity of 70 meters per second, and the negative 30 represents the direction it is headed, as you can see here. We found that it was 60.6 meters per second. For the initial velocity in the y direction, it was negative 35 meters per second. The final velocity in the x direction was 29.5 meters per second. And the final direction in the y direction was 5.2 meters per second.
We used this equation to find the impulse. We plugged in 80 kilograms for both equations for the mass, and then plugged in the final and initial velocities for both equations. In the x direction, we figured out that the impulse would be negative 2,488 newton seconds, and for the y direction, it would be 3,216 newton seconds.
To solve part A, we need to find the net impulse. We did that using this equation. We input the impulse in the x direction and y direction into the equation to find that the net impulse is 4,066.1 newton seconds. To solve part B, we need to find the force exerted on the driver during the collision. We did that using this equation. We input the net impulse, force as a variable, and the change in time as 14 milliseconds. When you divide 14 milliseconds on each side as 14 times 10 to the negative third, we are left with the force exerted on the driver during collision as 29 times 10 to the fourth.
Oh, Rohan, are you okay, dog? That 29 times 10 to the fourth newton is tough, man.
That's a lot of force right there.
Oh, yeah.